So what do you guys remember about law of cosines? How is this law of cosines going to be beneficial to us?
I don't even know.
Not at all? Law of sines. For a law of sines, we need to know the angle and the side opposite of that angle in order to find any missing pieces. Law of cosines allows us to know an angle, but you don't need to know the side opposite of it. You can know the other two sides. Okay? Or you can just know the three sides and then be able to find the angles. So law of cosines is going to allow us to solve for the rest of the triangle if we don't know the angle and the side opposite of it. And here's our formula for law of cosines. A squared equals b squared plus c squared minus 2bc times the cosine of a. Okay, recall the angles and the side opposite of the angles are always represented by the same letter. Angles, capital letter, sides, lowercase letters. So here, if you know angle A, and if you know side B and C, what do you end up finding? Side A. Okay? And you could relate this to any of the other sides. So whatever angle measure you have, that's going to be the side measurement that you can find. Okay? So we're going to try this example. It says solve angle C is 57 degrees, side B is 24, and side A is 18. Since we know angle C, what side measurement are we going to be able to find? Side C. If you want to use a triangle as a diagram, you certainly can. So here C is 57 degrees. Side B, so opposite of it is 24. Side A, opposite of it is 18. And to solve it, we can first find our side C. Now notice when law of cosines is set up, the angle measure that you have, you know the two sides that are surrounding it, and then you can find the third side. So here, to find the third side, we're going to look for C. So we're going to say C squared is equal to, now up here we said A squared is equal to B squared plus C squared. So B squared and C squared are just your other two sides that you know. Okay? The letters don't really matter. It's just saying A squared is equal to B squared plus C squared minus 2BC. So you just want to use your other two sides. So if we're looking for C squared here, what's our other two sides? Yeah, 24 and 18. So we'd say 24 squared plus 18 squared minus 2 times 24 times 18. And then times the cosine of our angle C, which is 57 degrees. Does the order that you write 24 and 18 matter? No, it doesn't matter because you're adding between them. So it doesn't matter the order that you write it. And this really is something you can just plug into your calculator and just figure out what it is.
How come you use the 1257 when it says cosine A?
Okay, but once again, this is a general formula. The angle measure over here matches up with the side that you're looking for. Since we know angle 57, that means if we put angle 57, which is C over here, we are trying to find side C. You have to be able to take the formula and apply it to any side. You just type the entire thing in there and you're going to get what C squared is. What are you getting for C squared? Yeah. 429.43 is what you should get. If you are not able to get that, make sure that you actually squared the 24 and the 18. Okay. If you don't square them, you'll get significantly different answers. So now if C squared is equal to that, how do you find C? Take the square root of it. So when you take the square root of it, what do you get? 20 point what? and let's get 4 decimal places for this so we have something written down so we can use it in a little bit. 7227. So for your final answer, you would certainly tell me that side C is 20.7. Okay. But we do want to make sure that we leave 4 decimal places or leave it in your calculator. Sometimes this one, leaving it in your calculator, is a little bit more difficult to do, but it's certainly feasible. So now we have side C, which is over here. How can we get the other 2 angle measures? Well, we can't just do the inverse of anything. We need to set it up and figure out what they are. Yeah, now we can do law of sines, because now we have angle 57 and side 20.7227. So we have angle C and side C that are opposite of one another. So now we can do the law of sines to find it. So sine of 57 over our opposite side, 20.7227, is equal to, doesn't really matter what other angle you find. Let's just find A, sine of A over 18. How would you get your sine of A alone here? Times by 18. So if you take 18 times the sine of 57 and divide it by the 20.7227, you should get 0.7284. Yep. Yeah, 7285, that's fine too. And you can use your answer button here, or if you wrote down the 4 decimal places, just put the 4 decimal places in. So then how do you get angle A?
Inverse sine.
Yep, the inverse sine, so that gives you A to be what? So 46.75, so what would be to the nearest degree? 47 degrees, yep. Now if you have 2 angles, how do you find the third? Yeah, add them and subtract from 180. So you'll take 47 plus 57, and then take 180 minus whatever that is. So 76. So there we solve the triangle. Okay, so we still have to use law of sines, but only after we found our missing side. You guys remember that from geometry? Yep. Okay. All right, so let's do the other way how we can use law of cosines, which is if we're given 3 sides. So here we're given side A, side B, and side C. If you want to draw out a triangle, you certainly can. Okay? And so here, if we have 3 sides, what do we have to find first? We have to find an angle first. Now, when you are given 3 sides, I'm going to recommend that you find the largest angle. So how do we know which angle would be the largest here? It would correspond with the largest side. And the reason why is if you take the sine of an angle measure, even obtuse angle, so if you take like the sine of 120, you get a positive decimal. Versus if you take the cosine of 120, you would get a negative decimal. And we'll learn why that is actually on Thursday or Friday of this week. But cosines, you're going to be able to actually find the obtuse angle if there is one. Sines, you can't. So we're going to have to see if there's an obtuse angle first. So you always want to find what your largest angle would be. So we're going to look for angle A. Since we're looking for angle A, that means side A has to be out in front for your equation. So side A is 15, so you would start with 15 squared equals. And now what are your other 2 sides besides 15? 7 and 9. So you would do 7 squared plus 9 squared minus 2, times 7 times 9 times the cosine of A. And that is just following your law of cosines formula, which is derived from the Pythagorean theorem. You see a Pythagorean theorem in there? It's derived from that. So now how do we solve this? This we can't just plug straight into our calculators.
Divide the right side by cosine.
We wouldn't want to divide the right side by cosine of a. We want to get the cosine of a alone. So we want to view that as the variable. Okay?
Oh, yes.
So if we're viewing this as the variable, here's our variable, we want to get that alone. So first, what should we do with all these squares and the things being multiplied by each other? Yeah, we probably want to figure out what these are, right? So what's 15 squared? 225 equals. Now here we have two values that are being added together, so we can certainly combine them. They don't have any variables or anything on. So if you take 7 squared plus 9 squared, so 49 and 81, what do you end up getting? 113, you said? 130. Got it. 113 seems a little small. All right, 130. All right, and then what would our 2 times our 7 times our 9 be? Okay, minus 126 times the cosine of a. All right, now we're trying to get the cosine of a alone, so what would we have to do next? Yeah, subtract the 130 over. So we have 225 minus 130. Where do you get 90 what? Yeah, so 95 is equal to negative 126 times the cosine of a. We would not add the 126 over, no. We divide it. It's attached with multiplication. Okay, so 95 over negative 126, we're just going to get some decimal for that, right? And then how would we find the value for angle A? The inverse cosine. Yep, so you take the inverse cosine of whatever value you get for that. You can also actually put that directly in the inverse cosine if you want to. And once again, we want to leave this to 4 decimal places, so we use that to kind of stay exact. Okay, so there we are. So in our final answer here for angle A, what would we say it is to the nearest degree? 139. Yep, 139 degrees. And now we have to find our other 2 angles, angle B and angle C. Yeah, so now we can use law of sines. So what angle? We just found angle A. So how can we set up law of sines to help us find one of the other angle measures? Well, sine of 138.9353 over 15 is equal to, which, sure, sine of b over 7. How do we solve for sine of b? Times by 7. So we'll take 7 times the sine of 138.9353 and then divide it by 15. And you should get 0. Something like that. You guys get that too? 0.3065? Yeah? Then how do you find the angle measure?
Inverse.
Yep, take the inverse sine of that. What'd you get? Yeah, 17.8519. So what would we round that to? 18 degrees. So if one of our angles is 139 and the other one is 18, how will we find our third? Yep, so we'll take 139 plus 18. And then subtract that value from 180. And so what do we get for our third angle? Yep, 23 degrees. When you're finding the third angle, do you need to worry about all of the decimals that were attached to it? No, because you want the 3 angles to add to 180. So you don't have to worry about what type of the numbers that you use to round to it. Okay? Instead, you just want to make sure that your integers add to be 180. Guys, remember that from geometry? If you don't, hopefully